as a variable, the data type is a double. But there is a pair of brackets. It means the type of this variable right now is not double anymore. It is a double array. So my list is a variable. According to this way, it is easy to find that my list is a variable. And at the same time, because of the brackets, we know the type of my list is not double, but a double array. If you use the second one, it is also okay. From the perspective of syntax, it is also acceptable. But it is not so good because it is a little confusing. Why? If we write double write double after my list there is a pair of brackets. It means my list is an array. But in nature, my list is not an array. My list is a variable. The type of this variable is an array. Later, I will tell you the difference between reference variable and array. And reference variable is different. An array reference variable is different from the array. Just now, I use myself as an example. My name is Linda. Linda is my name. Because I use Linda as my name, so usually I do not make difference between the name of Linda and me. If you I will yes, right? But in nature, the name of Linda is different from the person Linda, right? Reference an array. Later, I will show you more details. Okay, let's continue. Once an array reference variable is declared, it does not mean the array has been created because unlike declarations for primitive variable of an array variable does not allocate any space in memory for the array. Only a storage location for the reference to an array is created. I have told you the reference variable or the array different variable is different from the array itself. An array reference variable is a variable. A memory space will be allocated, but this space is not for the array. It is for the variable. And inside the space of the reference variable, there will be a reference. The reference is the reference for an array. Just because there is a reference inside of the array reference variable, this variable can reference an array. Maybe confusing. It does not matter. You should remember at least. You should remember array reference is different from the array. So the declaration of an array variable does not allocate any space in memory for the array. Only a storage location for the reference to an array is created. If a variable does not reference to an array, the value of the variable is null. Null means the reference variable is to no array. You can assign elements to an array. That means you want to use an array. If you want to, you should create the array first. Well, how to create an array? After an array variable is declared, you can create an array by using the new operator with the following syntax. Data type, a pair of brackets. There is a size. The size means how many elements there are in the array, and the size is a fixed size. That means once the array is created, the size is fixed. New operator should be used to create an array. And then you can assign the reference of the newly created array to the array reference variable by using the assignment operator. That means the statement does two things. First, it creates an array using new data type array size. Second, it assigns the reference of the newly created array to the variable array reference variable. Please read the syntax again. Later, I will show you examples. Declaring an array variable, creating an array, and assigning the reference of the array to the variable can be combined in one statement as shown below. This is the general syntax. Here is an example. Double my list equals new double 10. 10 is in a pair of brackets. This statement declares an array variable myList, creates an array of 10 elements of type, and assigns its reference to myList. Well, please look at the example again. To the left, you can see a variable myList is declared. Because of the brackets, it means myList is an array reference variable. Double means in this array, all of the elements should be of double type. That means myList as an array reference variable should reference a double array. A double array means in the array all of the elements should be double values. Then please look at the right part of the statement. To the right, new operator is used to create an array. 10 means in the array there will be 10 elements. The size of the array is 10. Double means all of the elements in the array should be of double type. As you know, in Java, the double data type needs 8 bytes. So it means here this array needs 80 bytes because for each of the element in the array it needs 8 bytes. are 10 elements. So the whole array needs 80 bytes. Once an array is created, a memory space will also be allocated. How large the space is, it depends on how many elements are there in the array, as well as the data type of the elements. That means here you should know first how many bytes for a double value. Then you should know how many elements are there in the array. Of course, in this example, the array needs 80 bytes. Once the array is created, 80 bytes will be allocated. A space with 80 bytes will be allocated. Anyway, this statement declares an array variable myList, creates an array of 10 elements of double type, and assigns its reference to myList. Now please look at the figure on the screen. MyList is an array reference variable. It has its own space. In the space, there is a reference. The reference is the reference of an array. The array has its own space. The space is as large as to hold 10 double values. Since the reference of the array is stored in the variable myList, we can use myList to access the array. Although myList is not the array itself, myList is just an array reference variable. We can use myList to reference the array. Here I want to say it again. First, an array reference variable is different from the array. For example, in this slide you can see myList is an array reference variable. It has its own space. An array is different from the array reference variable. It has its own space. These two are two different spaces, right? So they are two different things, but they are so connected with each other that usually we do not make differences between the array reference variable and the array. You can use the array reference variable to access the elements in the array one by one. Later we will discuss how to access the elements in an array by using the array reference variable. After creating the array and declaring the array reference variable, the following step is to assign values to the elements. To assign values to the elements, please use the syntax in this way. Array reference variable, a pair of brackets. In the brackets, an index is given, and then a value can be assigned to the elements with a specific index in the array. For example, the following code initializes the array. The values are assigned to the elements one by one. Sometimes we call the values as element values. Well, once an array is created, you have known its size is fixed. It cannot be changed. You can find its size using an expression like this: array reference variable dot length. For example, my list dot length returns 10 according to the previous example. That means if you want to know the size of an array, you can use the reference variable dot length to get the size of the array. It's very simple, just remember. Well, pay attention. When an array is created, even though you do not assign values to the elements in an array actually are assigned with some default values. If the elements are of numeral primitive data types, the default values will be zeros. If the elements are of char types, the default value will be a Unicode with hexadecimal value of 0000. And if the elements are of Boolean types, the default values will be false. Let me say it again. When an array is created, the elements have some default values, and the default values are dependent on the data types of the elements. Even though you do not assign values to the elements of an array, array reference variable dot minus 1. In the previous example, my list holds 10 double values, so the indices are from 0 to 9. The array indices in Java are zero-based. Please remember that. Each element in the array is represented using the following syntax, known as an indexed variable. Array reference variable index. Index should be inside a pair of brackets. For example, my list 5. My list 5 means the element with an index of 5 in the array my list. This is the way to access the element in an array. Sometimes we call this as indexed variable. After an array is created, an indexed variable can be used in the same way as a regular variable. For example, the following code adds a value in mylist0 and mylist1 to mylist2. It's very easy. It's very easy to understand the meaning of this statement, right? We have two elements, mylist0 and mylist1. We want to add them together, and then the result will be assigned to another element, mylist2. It is very simple. Right now, we have known how to declare an array reference variable, how to create an array, and how to assign values to the array elements one by one. Actually, Java has a shorthand notation known as an array initializer, which combines the declaration, creation, and initialization of an array in one statement. This is the syntax. To the left, you can see the declaration of an array reference variable. But to the right, you can see there is a pair of curly brackets. In the curly brackets, there are some values. For example, we have a statement like this, double brackets, my list. The left part of this statement means to declare an array reference variable. The name of the variable is myList, and this reference variable can reference a double array. To the right, there is a curly brackets. Inside the curly brackets, there are four according to this statement, there will be an array. In the array, there are four elements. The first element takes the value. This statement declares, creates, and initializes with four elements, which is equivalent to the declaration and creation are in one statement. And then the assignment is separated as four statements. The assignment are done one by one. Sometimes you can use the shorthand syntax to combine the declaration, creation, and initialization of an array in one statement. But pay attention. This shorthand syntax must be in one statement. You cannot split it. Split it would cause a syntax error. That means you cannot assign the values in a pair of curly brackets to myList after the creation, after the declaration of the variable myList. You should put everything together. You cannot split it. Let me say it again. You cannot split it means you cannot declare the array reference variable myList first and then assign the values in the curly brackets to the reference variable myList. You cannot split it into two statements. It should be done in just one statement. Listen, here you have known we can use an initializer to initialize an array. That means we can declare an array reference variable, create an array, and assign initial value to the array at the same time in one statement. Here, pay attention. You cannot, the shorthand syntax must be in one statement. You cannot split it. Split it would cause a syntax error. Now, let me write something on the board. For example, I declare an array reference variable first, and then I assign three values to myList. It will be, this is the meaning of splitting. You cannot, if you want to use the array initializer, you should put everything in the same statement. Declare the array reference variable and at the same time create the array, and at the same time assign the values. You cannot split it into two statements. Okay. If you want to declare the array reference variable first, in the following time, you have to assign values 1 to the elements of the array. You cannot this way to make the visualization. Clear? Continue. Well, now let me show you an example. In this example, you will see how to declare, how to create, and how to assign values to an array, and at the same time, how to use the indexed variables. Please read the code for a while. In the main method, the first statement is to declare an array reference variable and create an array at the same time. Values is a reference variable. It references an array with 5 int elements. Right now, all of the elements take default values. All of them are zeros. Then there is a for loop. There is a for loop. First, I is 1. I is less than 5. This is a loop continuation condition. Right now it is true. So execute the loop body. I plus values I minus 1 will be assigned to values I. Right now I is 1. So according to this statement, values 1 will be assigned with a new value. It is 1. Then I will be increased by 1. I becomes 2. The condition is still true, so do the loop body again. This time I is 2. That means values 2 will be assigned with a new value. According to the statement, values 2 becomes 3. 2 plus values 1. Values 1 is 1. 2 plus 1 means 3. So values 2 will be 3. Then I becomes 3. The condition is still true. Do the loop body again. This time, value 3 will be assigned with a new value. It is 6. Then I becomes 4. Values 4 will be assigned with a new value because right now I is still less than 5. That means the loop continuation condition is still satisfied. The loop body will be done again. Values 4 becomes 10. 10 means 4 plus 6. The value of I is 4. Values 3 is 6. So 3 value 3 means 6. 6 plus 4 means 10. Values 4 becomes 10. After that, I becomes 5. At this moment, I less than 5 is false, so the loop stops right away. The program goes to execute the following statement after the for loop. Value 0 will be assigned with a new value. Value 1 and value 4 will be added together. The result of this addition will be assigned to value 0. Value 0 takes the value of 11. It's very simple. In this program, you have known how to declare an array reference variable, how to create an array, how to assign values to the elements, and how to use the indexed variables. I, well, look. Read the code by yourself first, okay? In your mind first, you should remember how to, actually in this example, we put everything together, right? We have discussed how to declare an array reference variable, how to create an array, how to assign values to the elements of an array, and how to use the indexed variable in the array. Right now, this program put everything together. First, please look at the first statement in the main method. To the left, an array reference variable values is declared, right? Values is a variable, so it has its own space. Let me use a rectangle to represent the space. You have known this is an array reference variable. It holds a reference, right? So let me write reference here. The reference is an address of an array. By using the new operator, an array with 5 int values will be created. So I use another space. The space is as large as to hold 5 int values. You have known the default values. Once the array is created, the elements will have default values. For the primitive data types, the default values of the elements will be zeros. So it means there will be 5 zeros in the space of the array. The reference of this array will be stored in values, so values point to this array. Every time when you access values, you can access the array. We use values 0, values 4 to represent the first and the last elements in the array. And we also call this expression as indexed variable. According to the first statement, we can draw a figure like this. Then there is a for loop. The initial value of I is 1. I less than 5 is true. So we need to do the body. Values I. Right now, I is 1. Value is I means values 1, right? Values 1 will be assigned with a value. I plus values I minus 1. Right now, I is 1. Right now, I is 1. Values I. Values I minus 1. I is 1. Values I is values 1. What is the value of values I? 0. And what is values I minus 1? Values I minus 1 means value 0. It is also 0. So here, every time when we assign a value to values I, we need to add I with values I minus 1. It must be 1. 1, 0, right? When I is 1, values I minus 1 means value 0. Value 0 is 0 here. So we need to add 1 with 0. The result will be 1. 1 will be assigned to values I. So here, it is reset as 1. Next time, I becomes 2. Values I means values 2. Values I minus 1 means 1. So we need to add 2 with 1, and then we get 3. 3 will be here, here. And then next time, I is 3. Yes. I minus 1 is 2. Value is 2. 3 plus 3 will be 6. It will be 6. And next time, I is 4. 4 plus 6, it will be 10. And then I becomes 5. If I is 5, the loop continuation condition is broken. So the for loop will stop. Then go to the next statement after the for loop. Values 0 will be reassigned. To add values 1 with values 4. 1 is 1, 4 is 10, right? So 11. It is 11. If you run the program, you will create an array, and at the end, the values in the array should be 11, 1, 3, 6, and 10. Okay, let's continue. When processing array elements, you will often use a for loop. Why? There are two reasons. First, all of the elements in an array are of the same type. They are evenly processed in the same fashion repeatedly using a loop. Second, since the size of the array is known, it's natural to use a for loop. The following are some examples of processing arrays. Initializing arrays with input values. Initializing arrays with random summing all elements together. Finding element in array. Finding the smallest index of the largest element in array. Random shuffling and shifting elements. Let's take a look at these examples one by one. Between 0.0 and 100.0, but less than 100.0. Again, a for loop is used. Very simple and clear. Printing arrays. To print an array, you have to print each element in the array using a loop like the following. Very simple. Summing all elements. Here, a variable named total is used. Use this variable to store the sum. Initially, total is 0. Add each element in the array to total using a loop like this. For loop is used again. Finding the largest element. Use a variable named max to store the largest element. Initially, max is minus 0. To find the largest element in the array MyList, we need to compare each element with max and update max if the element is greater than max. Please read the code. It's very important to know the nature of this algorithm. This is a simple algorithm. Random shuffling. In many applications, you need to randomly reorder the elements in an array. This is called shuffling. To accomplish this, for each element minus I, randomly generate an index j and swap minus I with minus j. Here, a for loop is used again. Inside the loop, every time, there will be two steps. First, to generate an index j randomly with 0 less than or equal to j, j is less than or equal to I. The second step is to swap. To swap minus I with minus j. By using this way, we can make a random shuffling. This is the picture to show you the meaning of shuffling. Choose a random j and then make a swap. Shifting elements. Sometimes you need to shift the elements left or right. Here is an example of shifting the elements one position to the left and filling the last element with the first element. Please read the code. A variable temp is used. This variable is used to store the first element in the array. After that, a for loop is used. By using the for loop every time, we can shift the elements one position to the left. After that, we need to fill the last element with the first element. The first element is the previous first element. It is stored in the variable temp. That means the last statement is to assign the value of temp to the last element in the array. By using this code, we can shift the elements one position to the left in the array. Java provides a convenient for loop known as a for each loop, which enables you to traverse the array sequentially without using an index variable. For example, the following code displays all elements in the array MyList. In general, the syntax is as follows. But pay attention. You still have to use an index variable if you wish to traverse the array in a different order or change the elements in the array. If you want to access the elements in the array sequentially, you can choose the for each loop. But if you wish to traverse the array in a different order or pick the elements in the array, you have to use the indexed variables as before. Let's discuss the opening problem that we have known at the very beginning of this chapter. The problem is to read 100 numbers, compute their average, and find out how many numbers are above the average. We know an array should be used. The code of this program is given below. Please read the code for a while. What can you get from the code? First, in this class there is only one method. It is called main. That means in this class there is only one main method. In the method, an array reference variable numbers is declared. An array with n elements is created. What is the value of n? N is obtained from the user. Suppose here n is equal to 100. Then there is a for loop. By using this for loop, we can get the summary and the average as well. Because here we are asked to calculate the average. If we want to calculate the average, of course we need to know the summary first. So a for loop is used to get the sum of the elements in the array. But pay attention, before the for loop, initially sum should be 0. After that, another for loop is used. In the second for loop, every element in the array will be compared with the average which is calculated before. If numbers I larger than average, count should be increased. Here, a variable count is used to record how many numbers are above the average. After the for loop, count is the correct number of numbers which are above average in array. After that, we can display the average, and at the same time, we can display the number of elements above the average. The framework is clear. By using array, it is easy to calculate the average. It is easy to find out how many numbers are above the average. Without array, it will be very difficult. Well, another problem is about deck of cards. The problem is to write a program that picks 4 cards randomly from a deck of 52 cards. Here, all the cards will be represented using an array, the deck, filled with initial values 0 to 51 as follows. First, an array reference variable deck is declared. Second, An array with 52 elements is created. Of course, according to code, you know the declaration and creation are done in one statement. After that, a for loop is used. Deck 0 will be 0, will be 1 will be deck 51 will be 51. All the cards are represented using an array named deck, filled with initial values 0 to 51. It's easy to understand the meaning of the code. Well, right now we have known we can use an array to represent a deck of 52 cards. But how can we pick up 4 cards randomly from the deck of cards? Well, now please take a look at the figure. As you know, there are 4 groups in the 52 cards, right? Now suppose numbers from 0 to 12 means the 30 spades. Numbers from 30 to 25 represent the 30 hearts. Numbers from 26 to 38 represent 13 diamonds. And numbers from 39 to 51 represent 13 clubs. If we want to pick up 4 cards randomly, actually, we can make a random shuffling first, and then just pick up the first 4 cards. After the shuffling, the elements in the array are reordered. So it is okay to pick up the first 4 cards after shuffling. Once the cards are the orders of the elements are random. So it means in order to pick up 4 cards randomly, we have to do 2 things. The first thing is to make a random shuffling. The second thing is to pick up the first 4 cards. But there is an extra step. The third step is to display or to convert the number as a card. We cannot display number 6. We should display the 7th card in the group of spades. Please read the figure and think about what I am saying. Let me repeat it again. We use numbers from 0 to 51 to represent a deck of 52 cards. Now we separate these 52 numbers into 4 groups. The first is spade, then hearts, then diamonds, and then clubs. In order to pick up 4 random cards, we can make a random shuffling first. After that, we just need to pick up the first 4 cards. But when we display the result, we need to display, for example, 7 spades or 7 hearts. We cannot display the random numbers which is in the range of 0 to 51 randomly. We should display the information about the card itself. This is the background of this program. Once we get the card number, how can we know in which group it is? We can use the division calculation. Card number over 13. Since the card number is in the range between 0 and 51, card number over 13 will create a result of 0 or 1 or 2 or 3. If it is 0, that means the card number is in the spade group. If it is 1, it means the card number is in the heart group. If it is 2, it means it is in the diamond group. If it is 3, it means the card number is in the club group. So, by using card number over 13, we can easily know in which group the card number is. Then how can we know which card it is in a specific group? Just use the expression card number mod 13. It will create a number from 0 to 12. 0 means ace, 1 means 2, 12 means king. So, at the end, once we pick up 4 card numbers from the array, we can use these two expressions to display in which group the card number is and in the specific group which card it is. Now, let me show you the code of the whole program. Please read the code. The code can be separated into 4 parts. The first part is to declare an array reference variable deck and create an array with 52 int values, and at the same time using an array initializer to create another array which is called suits, and in the same way to create another array which is called rex. That means in this program actually we have 3 arrays. One is called deck. In this array there are 52 int values from 0 to 51. The second array is called suits. It is a string array. And the third one is called rex. It is also a string array. Then the second part is to initialize the deck cards by using a for loop to apply the values from 0 to 51 by 1 to the elements. Then make random shuffling. You have known how to shuffle an array, right? To generate index randomly, and then make a swap. And then display the first 4 cards after the shuffling. In order to convert the card number is a card in a specific group, we need to do 2 calculations. Deck I over 13, deck I mod 13. The first will create the information about it, and the second